Today, our friend Dev Patel will present to us on heat transfer in turbulent flow. I request Dev Patel to present to us on heat transfer in turbulent flow. Yeah, please go ahead, Dev.
Good morning, everyone. My name is Hyun Patel. I'm from BSc Industrial Chemistry, third semester. I would like to present on heat transfer in turbulent flow. Sir, change. Heat transfer and turbulent flow. Turbulent flow and
Yes,
heat
can you
transfer
please come forward and
are
elaborate
some of
this?
the most important issues.
Sir, I am walking your way. Sorry, sir. I cannot help you.
I will sit here. Go.
No, sir. I cannot help you.
Go. Move the slides. Go.
The flow in the
Scroll.
No. You told me that I was walking your way. I will look your way. मेरी करो
Joshi, can you please scroll down the slide?
जब हम आपकी हेल्प करने जाते हैं आप हमसे आपने कितना चिल्लाया आपको पता है आप कितना चिल्लाए आपको पता है
Wasting time.
मैंने कहा मैं तो आपकी हेल्प करने आ रहा था ना आप लोग आगे कैसे किसे चिल्ला आपको पता है
सर नो
Are we going forward or not? Go and please.
आपकी गार्ड वाले से लेके फोन कर
also the is equal to the 0.74 for the target force. The non-uniform free dimension network calculus mode is used for modeling and simulation of the flow and heat transfer. The length is about 25 times of the target. Next. Moreover, surface temperature studies for the flows with the different Reynolds numbers. Reynolds number is the number that is used for the dimensionless number. Result shows that the mean tube surface temperature decreases by the increase the value of the Reynolds number, whereas the increase by the increasing the Prandtl number. It is also known as the dimensionless number. Moreover, it is observed that with increasing the Prandtl number, the tube surface temperature is more quickly stabilized. In many industrial equipment facilities, heat transfers in the tube cycle is the great importance, especially in cases where the tube flow is of the turbulent type with high temperature gradient and heat transfer rates, such as in heat exchangers, turbines, and solar collectors. Also, by knowing the principles of fluid flow and heat transfers in the tubes with heat flux on the cycle, physical properties of various types of fluids and nanofluids can be obtained. As you can see, this is the laminar flow and this is the turbulent flow. Laminar flow is like uniformly stimulated flow, and turbulent flow has no particular direction. It can be flowed by any of the direction.
The results of some of these problems
The Now these are some characteristics of the turbulent flow and hence mixing of these qualities results from fluctuation, unpredictability, rising of fluid masses. Turbulent flow contains wide rate of kinetic. These are the characteristics of turbulent flow. Now the flow in the starting heat transfer occurs at the channel wall. Turbulent flow due to engine factor develops of insulating blanket and heat is transferred very rapidly. Turbulent flow will extend the useful life of the process by slowing the build-up the precipitates on the heat transfer surface.
maybe we can stand here and take
Yes.
You will have full control on the side operation. You will feel more comfortable that way. I will be here. Yeah.
Now these are just some things that you have to keep in mind targeting turbulent flow. Many equipments manufacturing publish specific flow and supply pressure requirements to achieve turbulent flow. Advantage temperature control units, portable and central and pump tank station are designed to generate turbulent flow. However, actual flow of the velocity will depend on the proper design and installation of the system. Full-size pipes are full-size pipes and hoses are recommended to avoid restrictions the flow.
આપણે given presentation માં તાલી પાડે તો
Now, this is the conclusion that what we studied. We studied the heat transfer between the tube, turbulent flow allowed the auxiliary it is also that the outlet fluid temperature will be more uniform at a different radial distance from the tube center, which becomes more so in the case of radial number.
Excuse me, Dev. Can you please clarify us more on Reynolds number and the other number? Reynolds number and very good. Thank you. You see how pointed Dev is in answering. He is very clear and precise. That is the way you should answer. These two numbers characterize the turbulent flow. Please. Thank you, Dev, for on turbulent flow. But the objective, I tell you, students, the objective of the lecture series, Professor Hyun Kim Sir's lecture series is, I want to see the beautiful examples in our daily life. I expected, your presentation is scientific. You made very nice presentation, but what I expected is, some lively examples where we see the turbulent flow.
In the industries.
Yeah,
mostly every industries we have turbulent flow.
In Google, when we type, turbulent flow and images, we can get beautiful images, sir. That is the creativity I expected. Okay. When a teacher shouts, you should not get, offended. This is only to correct you. This is only to mold you. This is only to shape you, to make you know the value of time. Dev, when a presentation is made, what you did is very good. Within a very short notice, you did very well, even though you do not have proper material. But Dev, I expected some material from Senjal. In the Senjal book, there is beautiful, content on turbulent flow. It is not, it can be better. Dear students, I tell you the beautiful example. I have industrial chemistry 503 course students. They are very spontaneous. It was not even included in the CEC. Okay, CEC में marks के लिए नहीं, just out of enthusiasm, out of interest, the students have presented, collected so much material. Each student has talked, delivered the lecture for minimum 30 minutes. Okay, when opportunity is given, you should utilize the opportunity, students. Dev, thank you very much for the very scientific presentation, but much is expected from youngsters like you. You need to devote time, you need to be more innovative, more creative, but you did an outstanding performance. Okay, let us dear students, let us give a big hand to our friend Dev that delivered a lecture on turbulent flow.